Hello everyone, I'm Karthik Chandran, the Director of Data Science at Optisol Business Solutions. I have started a series of lectures titled Statistics Demystified, and I have put two classes of the lecture in these two links. I will also copy a link as part of the video to those two lectures. Those are introductory videos about analyzing numerical and categorical data. In this video, what I want to do is, as a follow-up to those two lectures, I want to do some code samples, a live demo of code samples, going through those topics that we discussed in those two lectures, analyzing numerical and categorical data. Okay, for those who are not sure what the screen is, this is a Jupyter notebook. I'm executing the code on a Jupyter notebook. A Jupyter notebook is a very popular notebook that'll run Python commands. It's very similar to R markdown documents if you're coming from R background. There are a lot of notebooks out there, but seems like Jupyter is a popular notebook. A notebook is a way of projecting code as well as content that explains the code within a single live document. So it has gained a lot of traction in the recent past. I have also uploaded this entire notebook in Kaggle. I will also include a link to that Kaggle, link to Kaggle where this notebook is published, so that the entire code that you're looking at can be easily downloaded and accessed in that Kaggle link. Okay, so what I want to do is, like, I want to use the Titanic dataset, which is a very common dataset, to go through these examples of analyzing numerical and categorical data. Titanic dataset has a bunch of features about the passengers who traveled in that doomed, Titanic cruise. The dataset has the passenger information like their name, age, gender, the class they traveled in, and so on and so forth. And then this Titanic data set has been used extensively in a lot of examples to predict, in machine learning examples, trying to predict whether a particular passenger survived or died in that mishap by using the passenger demographics as a set of features. Okay, the first thing what I'm doing here is I'm loading all the libraries that are necessary for me to run this example. Okay, this is the code. This is the code to load the Titanic data set. Okay, there you go. So this Titanic data set has the first line loads the Titanic data set, and then the second line prints all the null values in every column in the data set. Seems like the deck, and then the age has a lot of null values. The null values are not good in any data analysis because any aggregation function you want to do on these columns won't work properly because of these null values. So what I'm doing right now is I'm just doing I'm filling the nulls with some, I'm doing a forward fill. This is the code to do forward fill. Basically what it will do is, like, it will pick a value from a nearby cell which is not a null, and then apply that value to those null columns. This is a quick and sometimes not very sophisticated way of dealing with null, but in this example this is good enough for us. Okay, so I have filled the nulls, so we don't have to deal with nulls in this demo. So the first thing that you have to do in any data analysis is to see how the data looks like. So I'm calling that a Titanic. The Titanic is the name of the data frame that I have just loaded right here. So that's the variable name that has a pandas data frame, that is of a type pandas data frame, and then by calling the dtypes function on the data frame, I can list the columns and the data types. Okay, looks like there are a lot of these are the columns in the data set, and these are the corresponding data types of each column. And then another popular command that you can do on a data set as part of your preliminary analysis is just to select the first 5 rows in the data set to see how the data looks like. So this is the data, that under each of these columns. For those who have seen this data set multiple times, I think they all understand what these columns mean. For those who are not sure, like you can there are a lot of data definition of this data set available in Kaggle and other places. You can do a quick review of those data definition to understand what these individual columns mean. So in addition to this head function, there's another function called describe. This is a good function to give you a brief overview of all the numeric data type. So all the data types that are either int or float, the describe function selects those columns, and then it provides you certain aggregate measures of that individual columns, like the mean and the standard deviation, the min and max values, and the 25th, 50th, and 75th percentile values. It doesn't make sense for certain columns like this survived or passenger class, which are more like categorical columns rather than numerical columns. But since they have the integer data type, they are included in this describe function. But something like age or fare is a good we can review that the mean age of the passenger is close to 30 years, and then the standard deviation is 14 years. The youngest passenger is under 1 year, the oldest passenger is 80 years old, and so on and so forth. This will be usually, like, when you're not sure how the data is distributed in a data set that you're looking at for the first time, a describe function gives you a broad overview of the data distribution. Okay, so one of the most important part of this demo is to do exploratory data analysis using some plots. So okay, let me run my first plot. Oops. Something happened. Hold on a second. There you go. I think the problem there was, like, I was using this command, this single line comment on a couple of lines. So I should have used this multi-line comment instead. So that was the issue. So the issue is fixed. So histogram is a very popular plot to do exploratory data analysis on categorical variables. But you may wonder that I have taken age, which is not a categorical variable. It has a data type of float, I believe. And then how is this a histogram? This function plt dot hist for histogram is working against this numeric variable. If you call a histogram on a numeric variable, usually what happens is it will internally create bins. See, what it has done is it has created a bin of 10 years. So it has created a bin of 0 to 10, 10 to 20, 20 to 30 onwards, or something similar to that. I think maybe 9 years. So it has created these bins, and then based on the bins, the frequency of the passengers that are in that binned value is plotted along the y-axis. So histogram can be used to do a univariate analysis on both categorical as well as numerical variables. And histogram is one of the most popular and one of the easily understandable plot that's out there. Don't worry about the details of the code. Like if you're, this plot is being done through the matplotlib library in Python. The important takeaway from this class is not the syntax that's been used to generate these plots, but but instead the takeaway is to learn what kind of plots that you will usually use against what kind of variables in your data set to get an exploratory and initial analysis of your data set. There are some descriptions of these plots and then different types of plots and what and then their benefits as part of this like the content in this notebook. I have, like I said, I have published this notebook in Kaggle, so you can download the entire notebook and then read the content. Okay. So this is another kind of a histogram. It's called the hollow histogram. We made it hollow by playing around with this alpha values that makes the histogram a little bit transparent. So this is the histogram that we saw here is a distribution of the passenger age, all the passengers who traveled in Titanic. Here what we have done is we have seen the distribution across two groups of passengers, male and female. As you can see, like it seems like the number of male passengers are high across all these categories, all these binned age values than female passengers, and it seems like across the spectrum there are more number of male passengers and then female passengers. There could be some other patterns in the data that could be extracted by projecting the data across groups like this. So this hollow histogram is another important plot that we typically do as part of our exploratory data analysis. Next to histogram, the second important univariate analysis plot that performs univariate analysis is a box plot. I have created a box plot of the same data, which is the passenger's age, that I have used to create the histogram above right here. But instead of histogram, I'm doing a box plot. What this box plot does that the histogram doesn't usually do is it gives me the median as well as the interquartile range of the data, so I will know exactly where the data is concentrated, as well as to see if there are any outliers in the data distribution. Okay, so just like how we did the hollow histogram to analyze the data distribution across two groups, I have used you can use the paired box plot to do something similar. What I have done is like I have this is the distribution of passengers who did not survive, and then compared with the group who survived. This is the paired box plot that describes the data distribution of the passengers age across these two groups, those who did not survive versus those who did survive. There's not a whole lot of thing that you can infer from this particular plot, but a paired plot across these that projects this data distribution across two groups is usually very useful to see if there is any patterns in the data across these groups. There are like a couple of more examples of the paired plot that are somewhat more involved than the one we just saw. This is a paired plot that actually adds three, so again we are seeing the distribution of age across the genders male and female, but I have added one more dimension, that of the class that they have traveled in. So this is how this analysis develop. You do an analysis at a lower dimension to understand some basic metrics and patterns in the data, and then you'll start adding more dimensions on top of it to get a bigger and a higher level picture, or bigger and a more detailed picture of the data distribution. So this is a paired plot again of the age distribution across two dimensions, which one is the gender of the passengers, that's the dimension one, and the dimension two is the passenger, the class in which these passengers traveled in. Okay, this is another example of a paired box plot in which we are projecting the age, seeing the distribution of age across their gender as one dimension, and whether they survived or not along the second dimension. So this is a very similar plot to the plot we just saw here, except the second dimension that we are reviewing here is the passenger class, and then the second additional dimension that we are reviewing here is whether they've survived or not. Okay, next to histograms and box plots, scatter plots are very common and very useful plots for data analysis. Scatter plots are usually used to see the correlation or relationship between two numerical data columns. So what I have done here is I have a project, like in this plot, I think I didn't do so yeah, passenger age versus the fare they paid to get on the ship. So the age is distributed along the x-axis, and then the fare they paid is distributed along the y-axis, and then these dots in the scatter plot shows if there's any relationship between these two numerical columns. It doesn't look like there is any significant or relationship. It doesn't look like either the age affects the fare or vice versa. So I don't see any discernible pattern. But if you maybe another set of columns may show some kind of a correlation between them. Okay, so this is the same paired plot. Sorry, the scatter plot. What I did, what I want. See, this is the plot for passenger age versus fare. This is also a similar plot. That does the same thing. It compares the age against the fare. But what I did was I added one more dimension to this analysis, that of passenger class. So as you can see, and then this dimension is created using a color bar. So as you can see, the passengers who traveled in the first class paid a much higher fare than the passengers who traveled in the second or third class. It is quite obvious in the hindsight, but again, this is not a very complicated data set to start with. But in another more complicated data set, like these kind of, like, visualizing a plot across an additional dimensions like this will help you understand the data patterns, and then glean more information from your data visualization. Okay, so so far we have dealt with the analysis of numerical data, and then now we are doing the second part, which is analysis of categorical data. Analysis of categorical data is much simpler than analysis of numerical data, because categorical data are discrete data and they don't have a lot of moving parts like how continuous data, numerical data will have. For visualization of categorical data, there are two types of tables that are very popular. One is a frequency table, in which we are projecting a particular data. Like we are seeing the distribution of a data across only one dimension. For example, let me run this. This will show you an example of a frequency table. So this is a distribution of passengers, the count of passengers who did not survive versus those who did survive in this data set. Okay, so we are projecting a data distribution across one dimension of whether they survived or not. A frequency table like that is fairly useful in a scenario like this. Okay, so this one is also a frequency table, but a little bit involved. See, what's happening here is, like, I have taken that age, which is a numerical data type, which is not categorical, but I may converted that numerical into a categorical data by doing the cut function, which cuts the age into 5 categories depending on whatever you passed in the second parameter, and then on those categories I'm applying the cross tab function that will give me the frequency table. So as you can see, like, this is the distribution of passengers in this 5 categories of age. Okay, so these frequency tables project the data across one dimension, and contingency table, they take it one level above, so they project the data across 2 dimensions. And then this contingency table is probably one of the most popular, most commonly used data visualization in data science. Okay, so this is an example of a contingency table where I'm projecting the passengers across 2 dimensions. The first dimension is the class that they traveled in, and then the second dimension is whether they survived or not. So this is a typical contingency table that we will see in a lot of places. This contingency table has the raw numbers. If you divide by the column totals or the row totals, you can create proportions out of these numbers. And sometimes like viewing proportions is more informative than looking at the raw numbers themselves. So that's exactly what I did here in this last line of code. Let me execute it. So what I did was, like, this is the same contingency table as here, but instead of seeing the raw numbers, I have divided the raw numbers by the row total so that we can get a proportion. So it seems like a 60, as you can see here, 63% of the people who traveled in the first class survived, but only 24% of the people who survived in the third class survived. So to glean this kind of data patterns or information from the data across 2 categorical dimensions, doing a contingency table that displays proportions is one of the most popular and most useful like data visualization technique. Okay, so that's it. Like, so this so this entire notebook, along with the description of these different plots, is stored. I have uploaded in as a kernel in Kaggle, and I will include a link to that so that you can download the entire notebook and then execute it in your own computer. Thank you for watching.